Hello, welcome to session 4 of this part 1, level 1. I think it's part 1 anyway. Level 1, design and make anything. And I'm just going to start off by showing off some of the stuff that we've been making for you guys. For example, items like this. Now, I can't remember who made what. We just got the files and we sent it. So this is a nice little device here. Something similar here. If you haven't sent anything through, don't worry. You still got plenty of time to send something. We'll fabricate it. Little devices like that. I have no idea what this is. It's probably some kind of cheek plate, maybe. A couple of rings here. So this is ready for you, Abby, if you want to collect it. I've been meaning to email you all week. I do apologise. And a chair. You can't see it. Oh, let's have a look. Is that it? If you can't see it, then I apologise now, but it is there.
I think Vicky had a ring as well. That might be Vicky's.
Oh, well, this one. Whose is this then? Is that Abby's?
That could well be Abby's.
I should have known, shouldn't I? Chair by Rojan and some other goodies as well. Okay, so today it's going to be a session of 2 parts. The first part is going to be Fusion 360. Last week there was a question raised, and it was like about what do these coloured lines mean? What's the difference between like a blue line and a black line? Well, there's lots of different lines. So I'm going to start talking about lines. So I hope you got your copy of Fusion 360 booted up and ready to go. Following that, looking at my script, so I do know I am prepared, honest. It says. Following that, we're going to look at how to duplicate stuff. And yes, we can copy and paste certain things using a drag. We can also mirror stuff, pattern. We can project. And there is another thing, it's called derive. Some of this is a bit more advanced, but it is demonstrative, okay? And of course, this has been recorded, so you can refer back to it as and when you wish, okay? And then finally, I'm going to be looking at the browser again, because the browser is where a lot of things happen. And in this case, it's just about doing a little bit of organizing, how you keep on top of files, really, and the documents that you will inevitably create. What have I got in mind? Yeah, the group command and components. It sounds a bit drab. It's like, well, why am I making stuff? Well, in order to understand how the making happens, you need to understand these kind of ground rules. In the second part, we're going to be looking at 3D printing. We're going to be looking at primarily selective, not primarily selective laser sintering. We're going to look at selective laser sintering. I've got a video of that. It's really hard to demonstrate that live because it is messy. Okay. So my colleague Ben has helped me with that today. His last day working for the Fab Lab before going to Manchester. And then I'm going to do a live demonstration on stereolithographic printing, which uses like resin, essentially. All right, but first I'm going to share my screen, and you should see a blank, well, not a blank screen, that'd be bad. You should see a blank Fusion page. If you can't see that.
Yeah, we can.
Thank you, Ian. Thank you. Okay, so I've got a blank screen here. Now, as was asked last week by Gareth, it was like, so what is the difference between, okay, like these lines? Well, the first thing to understand is that line color is dictated by the environment that you are in within Fusion 360. So the default environment is called photo booth, and that is this white screen. Okay, this is photo booth. Now there are other environments. One of them is called what is the other one? It's called the grey room. If you're interested in how to access these environments, you need to bring your mouse, your cursor, to the bottom center of the screen, where you've got these icons like orbit, look at, pan, etc. Well, roughly in the middle, next to the left of grid settings are display settings. And if you left click on that, okay, we've got this whole gamut of things going on here, like visual styles, setup, mesh displays. But the thing is, it's environment. Okay, so you got these different ones like dark sky, ooh, foreboding, grey room, which is that one. Some people prefer that because the contrast between black on white or these other colors on white does not mix well with some people. So we have things like grey room, and also we've got other things like the tranquility. That one's definitely not for me. And finally, you've got the infinity pool, which doesn't look like much unless you scroll around like so. Yeah, again, I find that detracting from the joys and the pursuits of design. So I'm going to have it selected to photo booth. If you're using some other environment, I apologize now. I'm not going to be flipping backwards and forwards because there's too many colors. Okay, so colored lines. They've all got a job. They all have a task. And the first one we're going to look at is the blue line, okay? So what you need to do, you need to create a sketch in order for us to do this, to see this in action. So I'm going to go up to the Create Sketch button next to Design. If it happens not to be there for whatever reason, it's because under Create, it's been hidden. So you could go to Create and you could go to Create Sketch there. There are 3 buttons, and if you left click on those, you can pin that to the toolbar or unpin it. So if it's not there, you can pin it to the toolbar that way, right? So I'm going to go to Create Sketch, and I'm going to straighten that up, so that's wacky. And I'm just going to choose, I'll just choose that bottom plane there, the XY plane. Okay. Now what I want you to do is just draw a line, a curve, a single curve. So use the line tool. You can draw a spline if you want, that's okay too. But for all intents and purposes, I'm just going to draw a curve. That's it. Now, as you notice, it is blue. The reason why you get lines that are blue is because they are under constrained. And what that means is they don't, yes, they have a position within that environment, but they don't actually have any measurements measuring them from, say, the datum point. Okay. There is no indication of its length, and so forth. Okay, but that's okay. It's okay to have blue lines. And so, for example, if I draw a rectangle, that too has got these kind of blue lines. Now, what happens is that when it does become constrained, for example, if I draw a circle right on that datum point, I put that in there, and then I enter a number, in which this case would be 20. Is that okay? Let's zoom out. That has got a black line. It's got a center, it can be referenced, and it has a dimension. All right. Now the thing is, so what if you've got something that's got blue lines? It doesn't really matter because I can still extrude that. I can still create solid forms from that. It doesn't have to be fully constrained. Constraining is handy if you're doing something that is really prescriptive, like engineering drawings, okay, stuff that has to have real definition to them, right? So that's black and blue lines. Everyone following? Is that straightforward enough? Okay, so what if, for example, we took those lines, if I select them like so, and then I went to constraints up near the top, and there's a lock there, a padlock, and that's fix unfix. Well, if I do that, that has locked that in place, okay? And so what you notice is that blue line, those blue lines have turned green. That is locked in place. You can't move those. In fact, you won't even be able to modify that until you unlock it, okay? So they've got this kind of olivey green color. So I'll unlock those. I'll press escape because that's how you generally get out of the tool that you don't want to use anymore. There we go, and so they're unlocked. Now that color green is also present in another way, in another kind of tool. And this tool is called the text tool. Now, I'm not sure, I don't remember if Ian really looked at the text tool last week, but the text tool is a tool that occurs in the sketch mode, and that can be found under Create. And it's kind of near the middle of that pile there, you've got text. So I'm going to click on that. And I've got a crosshairs with a little A on it. And if I right click, drag one corner, and then not right click, left click, I do beg your pardon, left click, drag, left click another corner. I can even rotate that text box if I wanted to. And in the dialog box that I've just dragged under it, I can put in a sample text. Okay, so SLA PM E1 S4. Right. Somewhere, well, it should be in there. Where has it gone? Ah, that's right, because it's there. Right, so my text box is too small. Silly me. However, the thing is with this, you can't do anything with that apart from you use it for labeling. And that's really kind of handy. If you're making a sketch and you want to determine what that is, you would label it. However, if you want to actually use this text in terms of an embellishment, or you want to extrude it or revolve or whatever, anything like that, you would then hover over that text itself and then right click, and that brings up the menu. And down there under edit text is explode. So I'm going to explode that, and there you go. Again, that has turned those lines, those vectors green. Yeah, a bit confusing because they're not locked. Maybe if I select that and lock it, well, it's no difference, is there really? Okay. But what it means is that when you see text like that, it means that you can then go and extrude it, etc., etc. So if I finish this sketch here, just to demonstrate that it really does work, I'll just like extrude these bits here. Now, so I'm not extruding the bits in the middle, although you can do what you want. There you go. Boom, done. We've created a three-dimensional body. Okay. All right. So what have we covered? We've covered blue, we've covered black, and we've covered this greeny, olivey green. Well, if it's not olive green, whatever, it's green. Okay, color. Okay. Now we've got brown, and we've come across these brown lines before. These are stippled line. So you'd think there would be one in that square there, but obviously there isn't. If I just delete those, if I delete these, right, I'll set that in the middle, and there we go. So we've got a central point there. Got no measurements on it, but that's all right. But we've got these stippled brown lines, and stippled brown lines are construction lines. And to find construction lines, you can turn them on and off. You need to find the sketch palette, and the sketch palette might be tucked away, usually beneath the view cube here. It's tucked away to the right, and you can open that up. And this is where Ian showed, like last week, where you can turn things off, like constraints and projected geometries, dimensions, etc. Okay. But here at the top, you've got construction. Okay. You can also find center lines as well. And center lines, it has a slightly different symbol. We'll have a look at it in a minute. But for example, you could have that just on all the time. And anything you drew within sketch mode, like another rectangle, sure enough will form these construction lines. And as I might have mentioned before, construction lines are a way of creating scaffolds. So, as it were, they're really, really handy. But the thing is with construction lines, you can't really do anything with them. You can't extrude them or revolve them. You can't create solids or anything like that. That's not what they're there for. Let's just get out of that. If I select those, maybe I'd want to turn those into a center line. Now, center line is denoted, it doesn't matter if I zoom in or not. Center line is denoted by a short dash and a long dash. Okay, and that denotes the center of something. So if you are doing particular drawings and you want to say, I want to show the center of a circle, which is generally what you would do, if I get out of that, get rid of that, then you would use that center line. So let's change that. That's a construction line. Let's change that to a solid. So, and then I would want to put, say, a line through it. Maybe. And that would just say, well, you know, I could say, well, that is the center of something. Okay. Not the best example. All right, so that's construction lines. So that's 4 lines down. And there's another, I don't know, 9 to go. Not 9 to go, there's another 5, a really big one. Okay, so the next one is purple. And like sometimes you might think, well, why have I got a purple line? If you've got a purple line on your page, it is because you have projected something. And I'm going to switch to another, let's get out of that. I'm going to switch to another view here. So I've got this here. This is the work that was from level 3. This was created the other day by, well, I gave them help, obviously, but by one of our students who went and then printed this off. We'll have a look at that in a little while. But in order to create something like this, it did require things like projection. So if I turn those off and turn the sketches on, okay, so offset axis, yeah, okay. So you might think, well, what is projection for? Projection is when you want to create another plane, and that plane could be parallel with your pre-existing standard planes, like your X and Y, or your X and Z, or your Y and Z. And these would usually be parallel to them. That's not strictly true, though, as I will demonstrate in a moment. And you can then project profiles onto there. So, for example, I've got this sweep path. Okay, now this sweep path was used to create that shape. Okay, which is good. But in order to create this shape on top, and I'll have to turn the sweep part off, I had to project that onto another plane. Okay. And so projection is a simple thing. It's done in terms of sketching, sketch mode. So, for example, if I create another sketch, not that sketch, that's actually a bad example. There was a good reason why I had to project that. It's because I took the file of someone else and nothing was quite centered. Nothing was centered accurately anyway. So if I create a construction line, so I press construct there, selected a plane, I'm just going to drag it off. So, okay. If I then, well, as you see, I've right-clicked on that plane. I can create a sketch that way. Alternatively, I could just go to create sketch, select that. It says. Now, to do things like projection, you have to go to the create menu under the sketch tab. Yeah, so sketch is highlighted in blue and underlined in blue. Go to create and go to project. And I can just grab that literally. And as you can see, it's highlighted in a dark purple. I can link that projection, and what that means is that if I change the result of that projection, it will change the original file, and vice versa. So you have to you use it with caution. Go okay, and sure enough, oh look at that, it's blue. The reason why it's blue is because it's not linked. But I'll do that again. Demonstrate that again. Where's that problem? Oh, it's still live, isn't it? Still live. That's all right. Let's delete that. As you notice, because I'm basically selecting a sketch from, I'm selecting lines from a previous sketch. Those lines have to be on. So in the browser, under my sketches, I've got sweep path. If I turn it off, you can't see it. If you can't see it, you can't project it, basically. Okay, so I'm going to go project again. So I'll link it this time. Go OK. And there you go. So that purple line refers to it being a projection. Generally speaking, that is linked. I have come across instances where that isn't the case. Also, you might notice if I turn that sweep path off, if I hover over that, there's a little symbol that appears, and it's of a cube and basically like what looks like a surface with a square in it. That's the symbol for projection. All right. So I could select that, and if I go to break link, sure enough, that's no longer purple, it's gone to blue. It's treated as an entity in its own right. Okay? Is that straightforward so far? Please tell me, or Ian, if it isn't. Now,
I've just got a yes. Nobody said no so far.
I'm scared. No, don't make a rod for my own back. Okay, so the thing is, yeah, I've projected a curve. You can project like solid bodies or outlines. I've been doing that today. I'm trying to make a mold for an injection molding course that I'm running next week. I'm trying to make a mold to injection mold these little guys here. I'm holding it up to the camera. You probably can only see it on the little screen of me, if it's there. It's really difficult. However, so for example, if I say, ooh, I want to project this shape here, I want to project that onto, say, the top plane, and you would see that outline or outlines. So I could go create sketch. Yeah, here we go. I'm going to rotate that around. If you're wondering how you rotate stuff easily, it's all in the view cube in the top right corner. Yeah, like that. Boom, bish bash bosh, lovely. Then we go to create and then project. Sure enough, I can project particular entities. Now this has got loads of fillets on. What you might notice about projection when you're using this tool is that you can only select things one at a time. You can't do mass selection like drawing a marquee box over stuff. It's really annoying if you ask me. I find that particularly irksome, especially if you're trying to project something like an outline, if that's all you're after. Yeah, so I could be here for a month of Sundays, so to speak. And if you don't know what I mean by a month of Sundays, it means forever. Okay, I'm nearly there. In fact, I could have only just done one side of it. Okay, I won't need that, and I'll go okay. The thing is, if I turn that upper horn off, I've got some kind of profile. Why it hasn't shown the other profile, I don't know, the outside profile. Who knows, but that's how that works. So you can project from bodies, from surfaces. You can do them from meshes. That's different. That's a lot more difficult. I'm not going to talk about that right now. Okay. There are other ways of projecting stuff, but well, I mean, I think we'll talk about. I'll probably talk about that in maybe 2 weeks' time when we look at machining. Okay, because that we'll have a look at what it means to do inspect in all these tools here, or some of them. All right, so that's projection. So following on for that, we've got yellow. There is a yellow line, and that's when a projection fails for whatever reasons. I've never come across it, but apparently it's true. Okay, so if I say use that body number 9 again, well, I've got a feeling that I'm still, I can't be sketch. Oh, that's body. I haven't used that sketch. All right, so I'm going to create another sketch. Oh, it's still there. Look at it. What is that? Ah, that's because it's up here. That'll be why. Interesting. All right, whatever. Let's turn those guys off. So I'm going to create a new sketch, and the reason being is that I want to create overlapping bodies. Visible. All right, where are they? Oh, it's because I've turned them off. Yeah, that's better. So if I do this, I'm going to create a series of sketches that overlap. And what I'm going to do is I'm going to extrude them. Okay. And this will show you an example of where you will see a red line, because you might be wondering, what's that red line about? You might not. You might not be. Where is it? Right, there we go. Okay, so we've got these. You've got these features here, like that. So I've selected that, and it's got a red line around it. What that red line is asking, it's actually asking you a question in its own weird way. It's like, are you sure you want to select that geometry? Do you want to select the adjacent geometry? I was like, well, maybe I do. Maybe I want to select this one as well. Okay, so now we've got a red line that extends around these other unused areas. Obviously not around the outside though. Okay, so this is where this is where you will see these red lines. And sure enough, you get them there. But you notice this is not in sketch mode. We're out of sketch mode. We're in a mode where we are using solids. And sure enough, I could just extrude those upwards if I turn the bodies on. I'm sure nothing else is on. Okay. Straightforward enough. Okay. So those are the main kind of different color lines that you're going to encounter when using Fusion. You might be wondering what they're for. Generally speaking, you don't even need to think about it. I mean, Fusion is quite intuitive in its own way. But there are other lines and there are other curves. So, for example, if I go to Origin and turn the Origin tab on in the browser, sure enough, we've got these axes. Hello, it's kind of gone a bit, whoa, it's gone a bit funny there, isn't it? Zoomed right in. And as you can see, well, like the x-axis is, well, all these axes are those center lines, as I showed you earlier on with the construction lines in brown. They're the same, these are center lines. So these will represent a center of something, usually a center of rotation, okay? But in this case, they denote where the planes, the boundaries of that plane, well, not really the boundaries, the parameters of where those planes exist. Yeah, that's really annoying. That's better. Still don't like it, is it? Okay. So in this case, you've got red, which denotes X, green, which denotes Y, and this darker blue, which denotes Z. Well, that's all well and good, but there is another color axis, and it's turquoise, or near enough, like a light turquoise. Okay, and that is called an offset axis. So if I went to construct up here, I can say, oh, offset an axis. It's not as simple though as say offsetting an axis through offsetting a plane. You need other criteria. It says offset an axis through two planes. So maybe if I select that one and that one, yeah, that kind of follows that that x-axis, not the x-axis, the y-axis. Well, that's no good at all. So usually you need other criteria for this kind of thing. In which case, I'm going to use this sketch down here. If I activate that, that's better. I don't know why this is all a bit bugging out at the moment. Let's have a look. It's because it's zoomed in so madly, wildly. That's better. That's it. I think if you zoom too far into something, it does throw a wobbly. Okay, so in order to create this kind of thing here, I had to emulate this thing at the bottom. And these are made by sweeps. Okay, so we looked at sweeps earlier on. Okay, I can refresh your memory if you want on sweeps. I'll do that now. Got that and got that. And the sweep is merely this. You have a path, which is that. And then you have a profile, which in this case is this. Okay, the circle. and all the gubbins in the middle. Okay, and so you have to have two sketches. Generally speaking, they don't exactly have to be perpendicular to each other, i.e. at a right angle. So if I go there, you can see that line there is roughly at a right angle to that, to where that curve leads. But they have to have a relationship like that. So they have to be on two different planes. So if I go to sweep, and the dialog box wants me to select a profile. Well, I'm going to select the path first. There's the path. No, so they don't even have to be touching. They've just got to be near. And the profile, well, I suppose I could. I haven't even selected the flower, but there you go. So that's how sweeps work, right? And that's how I got that shape, in all honesty. In fact, if I just, that's even better. I like that. You can put a taper angle on that, which I did. It's 5. Obviously, it doesn't like it. Let's get rid of that profile. Select that again. There we go. So that's how I created that horn shape. Now, the thing is, how do you create this other offset shape? You know, how did I go about that? Well, I had to create a construction plane. Well, that construction plane is at an angle. Okay. Now, usually, I mean, maybe I could have created a construction plane from, turn that off, by rotating it around that z-axis. I went a different way about it. I did it through 2 points. Point through the center of a circle and roughly at the end here, or a midpoint that I kind of roughly worked out. And sure enough, if you go to construct, you can go perpendicular to that point. No, it's the wrong one. Through 2 points, there's one. There's the other. As you notice, this is not in sketch mode either. And so what that means is that you can use information like point information or line information from multiple sketches and multiple planes. And sure enough, there is that offset axis. Yeah. What would you call that axis? I don't know. Offset? N, maybe? Whatever. It's up to you how you label that. I called mine offset axis sweep path.
I'll go for W.
You'd go for W. Why is that?
WX. Oh no, it's the wrong one. It would be, yeah, WXYZ. There you go.
Brilliant. You could call it A. Because I think that's what they call it in machining terms, the A axis. But anyway, W is good enough for me. Okay. So it's the wonky axis. All right. And from that, you can then create other paths, other construction paths. I'm not going to talk about that because that's not about lines. Okay. But as you can see, there is another colored line. Brilliant. Okay, so that's the lines. But the thing is, there are other colors. So what happens when you hover over, say, like a vector like that? Well, it goes a dark blue. And if I select it, it even goes what looks like to be a richer blue, or maybe it's just thicker. Yeah, so it is. It's like pale, medium, or whatever. And slightly more intense, slightly deeper hue. And it's the same. So when you've got a closed circle there, a closed curve, the inside of it will be highlighted in this kind of pale blue. And that denotes that you could then extrude it or do whatever to it. It means you can make a solid. If it wasn't like that, you could then make a surface, but that's a different ball game altogether. So if I select that, sure enough, it highlights that in a darker blue. And sure enough, there's those red lines. All right, how are we doing for time? Well, it didn't take me that long to get through that at all. I was expecting that. Oh no, I'm on time. Brilliant. Okay, so any questions about lines? As fascinating as that was, I mean, that was proper nerding out. But you know, that's what it takes. Okay, so I'm going to move on, and this is about how you duplicate stuff, how you copy stuff. So I'm going to close, no, I'll keep that open, I might need that. So I'm going to go back to this untitled file. I've got a sketch that is just a point. And I'm going to go to edit sketch. Now we've covered this before, but for example, I don't know, right, you can have a go at this as well. I'm going to create a circle. That's a construction circle. So it's 120 millimeters in diameter. All right, and as you can see, that's gone black, even though it's a construction line. So there's another color, a stippled black line. It means it's constrained. All right, but I'm also going to go to create. I'm going to go and find that polygon tool under create there. I'm going to go to circumscribed polygon. Right, it's not going to latch onto anything, but I'm just going to stick it there. It'll latch onto the line, but there's no points. And I'm going to say I want that, I don't know, 60 millimeters. Maybe a bit too generous, that maybe 40. I don't like it, maybe 25, there we go. Done that, and if I press the tab button on the keyboard, which is usually above the cat lock button, it switches down to here. Oops, 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 oops. It switches to this box here. What it should have done. I'll get over there. And then there, I'm going to change this number of sides. Well, I quite like 9-sided objects, but yeah, like the 50p piece. Okay, big deal. Right, I'm going to change that to a solid line. I'm going to select that and change it to a solid line. Okay. So the first tool, it's under create, and it's called pattern. All right. And this is a way of making copies of something. And you've got circular pattern and a rectangular pattern. If I go rectangular pattern, it will array it in like 2 directions. Sometimes that, yeah, it'll only array it in 2 directions. So one direction, let me see now. I've got 3, so I might want 5 in there in one direction. Oh, where's it gone? It's gone down there. And then 5 in the other direction. But now I'm going to give it some meaning. So I'm going to say it's what, 30 millimeters. Are they suppressed? Probably. Let's turn that off. Let's have that 30 millimeters. Directions. Gave you the direction. Silly sausage. Oh, hang on a minute. I haven't selected anything. What have I done that? Okay, right. So there we go. Boom. There's 3 in that direction. It's reset itself because it's covered like that. And 3 in that direction. And that's called an array. Now, in this dialog box, you've got something called suppress. So if I strike that, I can untick the ones we want to keep. If I can get my cursor on there. Oh, hang on. He says I can keep the ones I want to keep. Well, it's obviously not letting me do it. So, oh, there it goes. It's very jittery. Very jittery. Okay, and that one. Go on, get out of it. Go on, soon look. Okay, and if I go OK, that's all in one direction. Naturally, you can go in symmetrical. You can do it in one direction. Lovely. Increase the number if you so wish, like that. Beautiful. Okay. And there you go. So I've got a pattern there, but it hasn't done them all, and that's the suppress function. So, but as you can see, that's a way of copying. And I'll do that. The other one is circular. And I'm going to say right now, if you're doing this kind of stuff, if you're not careful, you will grind your processor to a slow halt. And the reason being is, well, we don't really know why. This kind of architecture that this software uses, anything like vectors like this and curves, like 2D stuff, it has a trouble dealing with it. It is irksome, but it's just one of those things. Right, so I've got the object. I'm going to select that. My center point is here. And there we go. We've got that suppress function there. And I can increase the number of these if I want to overlap. Okay, I've got 9 there. 9-sided figure, 9-sided doodah. And if I undo the suppress, I'll have all of them. Okay. Now, once you've got something like this, oh look, I've got some interesting star shape in there. Very nice. Once you've got something like this, you can then extrude it or do other stuff to it. You could even sweep something like that, although it might be a good idea to trim the bits you don't want or whatever. Or you create a file like this, a sketch like this. This is your base sketch, so to speak, and then you create duplicates of it by projecting onto other sketch planes, and thereby you can select the material you want, the elements of those sketches you want for that particular sketch. Okay, so that is revolving, heavy on the processor for some bizarre reason. All right, let's go back. There is another way of duplicating stuff, and that is mirror. Okay, the mirror function. Now the thing is with the mirror function, it'll say, right, select an object. Well, I can select individual components of that. I can select the whole lot, like that. But the thing is, I don't have a mirror line, do I, at all? Can't even select that curve because you can't use a curve as a mirror line. Okay, so what that tells you is that you have to draw some other curve to use as your center of reflection. So in which case I'm going to just draw a line from the center upwards, and this could be just a solid line like that. As you notice, that's constraint, or it could actually be, it could be a construction line, like that's thus. I've got a mirror icon up on my toolbox at the top because I use it a lot. So I'll select it down there. So I'll select that first. I'll select that, and voila, we've got a system. It now has a twin, a symmetrical twin. Okay. So, all right, that's 3 ways of copying. Obviously, I showed you another way of copying, which was in the previous demonstration about lines, and that is projection. And sure enough, as I said, you could project that onto another construction plane or plane even. No worries at all. Easy to do. Okay. So, for example, I might only want a certain aspect like that, and I'll just project it. So, but I might only want these bits here, these bits here. It's a shame that if I want that, it would project the whole thing, but whatever. Okay, here we go. And that's what you're left with. Right, so that's that other way of copying. All right, so that's all well and good, like, you know, copying, arraying, things like that. That's all good for sketch mode. But what if you've got things like bodies and surfaces? Okay, so if I grab these things that I've created here, and I say, well, I want to extrude these, both of them. Okay. Well, actually, tell a lie, I'm going to extrude one of them. Okay, it's fine. Yep, good. I'll turn those sketches off, don't need that. The same rules apply to sketching in a way in terms of arrays and mirroring. So sure enough, I could mirror that. Again, I've got that tool on top, so I can just get to it really quickly, or I can just go to create, and it's kind of below the halfway mark, says mirror. So I can either select faces, and I could do multiple selections of faces. So where's the mirror plane? Well, the mirror plane, it can't be a line as such. It can't be a sketch line. It has to be a plane. You can't use an axis. So I've got a plane here, and sure enough, I've just mirrored that. I had mirrored that across, but I don't know where it's gone. Error. It's because I created a surface, isn't it, basically? Okay, so maybe I will do that in surface mode. Let's do that again. That's because you're choosing individual components Well, no, not components, individual features of that solid. No, it didn't like it. If it says it didn't like it, compute failed. Well, that's weird. Oh well, it is what it is. Okay, so I'll go to mirror again. I'm not going to select faces, that was nonsense. I'm going to go bodies. Okay, that's the body. There's the mirror plane. There's the mirror plane. New body. Yeah. Okay, and there it is. Oh, that was palaver, wasn't it? All right, so get rid of that. And again, I can array that and pattern it rectangular, circular. I can also pattern it on a path. And if you're wondering what that's all about, I will show you very quickly. Sketch, let's get rid of those guys, don't need those. And I'll create a spline. When you edit it, when you're doing stuff with splines like for sweeps and paths, you've got to be careful that it isn't too sharp because it won't like it. In fact, it will probably fail. So if I go to pattern on a path, there's the object, not again, not faces, they're bodies in this case. There's the path. Then I can pull that along. Again, you've got that suppression thing. Choose a different number. Oh yeah, look at that, lovely. Now the orientation could be identical, so basically that face there will be the same on all of them. Alternatively, you can select path direction. So as they move along the path, they will rotate accordingly. So this face here, let's say it's this face here, or probably this face here, will always be perpendicular with that path. All right, and that's how you create multiples in the direction along the path. Very handy, very, very handy. Okay, so we've done mirroring, we've done, I'm not going to show you the circular one, because you don't need to, you've seen it in the sketch, it does the same thing. All right, but feel free to have a go at that. Okay, now there are other ways of copying things like bodies, and I could either just click on it, right click, I could go to move copy. Yep. And if you notice, when you use the right mouse button on the screen, whole list of things that you can do, particularly like repeating stuff as well, and push, pull, and whatnot. So if you go to the browser, right click on that, and I'll go to, don't go to anything, does it? Right, there we go. And let's move copy. All right, so to do this, you're going to create a copy, and it's a tick box at the bottom. Otherwise, all you're doing is moving. And you can move it in all sorts of different ways. I could move it freely like that, and I've made a copy. I think it'll only make one copy. I can move it in all sorts of directions as well. So if I undo that, but you've got to create a copy. But as you see, it only creates one copy. But I could also move it. I could rotate it. I can translate it. To move it to a point to position or point to point. So I can go point to point, and origin point select, and I'll select there. Target point, I'll select there. And sure enough, it's moved it. Oh, of course, I need to copy it. There you go. So there's the other way of copying and things like that. Really, really handy. Okay. Now these rules apply to things that are called components, and I'm going to have a look at components in a minute. All right. Now there's one last way of doing stuff, of copying stuff, and it's called derived. Derived's more advanced. Okay, so you know, don't, as I say to all students, no matter what you're studying and stuff, I don't expect you to remember everything at all. It's just so much to take in. But in this case, I'm going to use this as an example. This is my European funded research. It's a press to squeeze material into things like new trays for fruit and veg and whatnot. So there's the model I'm using at the bottom. If you notice my browser on the left-hand side, everything is labeled. Everything. Nothing is unlabeled. Nothing is untitled or sketch one or whatever. Don't believe in it. And when you're involved in projects like this, or you're creating things that are complicated, you need to be pretty savvy at doing it. Okay. But anyway, so let's get rid of those, and let's get rid of that. So there it is. There's the lower part of the press. Now the thing is, in order to create that, I had to use a derive function. Well, I did and I didn't. But so that's the thing I want to make. Okay. It's not easy to create that kind of thing, you see, straight away. It just isn't. So I had to create that in a very specific way. And the reason being is the dimensions of it on the top are different from the dimensions underneath. That's how it has to be in terms of making a mold. All right. So what did I do? I think I've got to find the original. It isn't so easy, even if it's all really well organized. So there's the body, there's the prevalent face. It's not prevalent face, we don't want that. Is it the upper former? It's the lower former. I don't need that. Just bear with me a second while I get my act together. Port dilution block and portray. Let's have a look. No, it's not that one. It's different versions. Okay. Well, that might. Which one is it? It's not that one. It's that one. All right. So. Okay. So derive. What derive? In order to derive something, you have to. If you were ever to do this, you have to have it as a saved project. So I know this isn't saved because right at the very top it says AGK Apple Trade version, whatever, blah, 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 blah. But at the end it's got version 35 asterisk. And you've got that little star symbol, that asterisk, it means it's not saved. You can't use derive. Okay, I'll give it a go. But derive can be found, it's in solid. I think you probably might even get to do it in surface. In fact, it's its own thing. Doesn't matter in what mode you're in, you can use it. But there's derived. Derived design elements such as components, bodies, sketches, work geometry, flat patterns, blah, 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 blah. Okay, and use those elements, update with changes to this design. You can do. So I'm going to go at derive, but instantly requires the save, it requires saved source design. Well, I'm just going to do it that way. I mean, I could have done it like that. Boom, done. Okay. Right, so now I can use derive. And it comes this, it creates, I want to create a new design. I could add it to an existing design, but I'll create a new design. Excuse me. And it is model object, so select. There it is, there it goes. There it is, the bodies. It's just called it body 1, even though it's actually version 6.01, whatever. Place objects at the origin, so when I open this up, it can be right in the middle. It's a handy function. And we go OK. And sure enough, there it is. There is a working copy of that. All right. And you might be wondering why you would do that. Well, I did that for a simple reason. It's because I needed surfaces. I couldn't achieve what I wanted to achieve easily without using derive. I couldn't achieve that difference in, let's get rid of those guys. I couldn't achieve that difference in the upper and lower form. So there, that smaller form there, and this upper form there. So derive is very handy. But as I said, this is advanced, okay? This is advanced, but feel free to play around with it because that's how you learn how to use stuff, by mucking around with this stuff, all right? In this case, I just unstitched stuff. I unstitched the whole lot. And then I deleted stuff. And suddenly that went from being a solid instantaneously becoming a surface. All right. And then I went to stitch, and then I selected it all together. And I went OK. And then it became one single surface. All right. So that's copying and arraying and moving and whatnot in a nutshell. You got any questions regarding that? That was a lot to take in. It is a lot to take in today. So glad that this is being recorded so you can watch it back. Okay, you might never use any of these features, but that's okay as well, right? So am I good to progress? Okay. Hello. Someone's typing. Cool. All right.
Looks good.
Yeah.
Oh, just can you recap an offset plane from Gareth?
Yeah, absolutely, Gareth. I can do that totally. Right. So let's see now. Why do we want an offset plane? Okay, so we want an offset plane. I'm going to turn on origins. I tend to turn it off because they get in the way. And again, you can turn stuff on and off whenever. So, for example, I've got this object here, this 9-sided three-dimensional extrusion, and I want to have something that I want to create a plane on the top. Why? Who knows? But to create that offset, there's a box here. So this will appear either if it's in solid or surface in sheet metal, but not tools. You'll have it solid. It's called construct, and there's a drop down menu there. So if you left click on that, you've got all of this stuff. The ones at the top, you can see it's in 3 sections. The one at the top, these are all planes. In this case, I'm going to say offset plane. It is the default tool that's there. Now, like other tools, I could add them to that box. So I could say, well, I use offset plane a lot, so I could have that there too. But the truth of it is that I don't at all. So I only use offset plane, but it is all about customizing it to what suits you. So I'm going to go offset plane. Now the thing is, you need a starting point to begin with. It says select plane. It's lying. You don't just have to select. You don't have to select a plane. You can select a surface. All right. Boom. There you go. I've instantly created an offset plane from a surface. All right. With which I can move independently. Notice I can only move it perpendicular at a right angle to that plane. Yep. But I could select that plane too. And that I know for sure will definitely be parallel to that XY plane. There we go. It's the same. But I might want to select that one, and you can see you can build up really unusual planes. So that's how you make a construction plane. However, say you want to select that plane and you want to offset it a set amount of distance, but you don't know what that distance is. Well, where it says extent, you can go to object. And I can say, well, I've got a point there. And lo and behold, I select that point, that corner, and it's extended that construction plane, that new plane, level with it. Right? It's a really handy feature because if you're creating complicated models and whatnot, they can be very difficult to measure, like distances. But sure enough, this is a way of doing it, and then you can measure the distance between those planes or whatever on those planes. There you go. So once it's made its mind up, in the browser, once you can create construction planes or axes or even points, right, you know, points like that, it gives it has its own name. Be really thorough about how you name your construction planes. So, I mean, okay, if you're using one and it has one job, that's fine. The offset, what offset was that again? So I didn't see that. Ian, what was that question?
And I'll just read that out. That says that's useful. Thanks. I think I asked the wrong question. I meant the offset when you were sketching.
Ah, offset. Yes. Well, actually, that's another way of copying that I didn't cover. And thank you very much for highlighting that because I didn't even think about it. Okay, so let's get rid of that body, and I've got that sketch there. So let's have a look. Edit sketch. Offset is a tool. It's a modification tool. Yes, you're creating something, but it's something you modify. So up the top here, I've got create. I'm in the sketch mode. You see it's highlighted in blue and it's got a blue underline. So I've got create. It's next door. I have it permanently there and extend. But there we go. If you drop down that menu, it's near the bottom. Offset. Offset's a curious function in Fusion. So if I do that, firstly, it's got chain selection. If I unclick that and say just unclick that, so it's not chained, I can select each individual object. They have to be together though. They have to join. You can't do one in the middle of nowhere. Not this time around. You can do it on another occasion. But if I just chain that selection, and I can drag this bar in or outwards. Some things do not offset easily at all. Sometimes it will throw an error. Okay. There might be reasons for that, and that might be because you are using something that is a projected geometry, and there might be something about that projection, not that it's locked or anything. There might be something about how that projection was made, or the lines that you are given, those vectors. It doesn't do it. But there you go. You can flip that either side if you want. All right. Now the thing to note about using offset. So if I offset, say like 10 millimeters, that line that I've created cannot offset it. It's a curious thing. There we go, it throws an error. One or more, yeah, there we go. One or more of the selected curves has already been offset. Consider offsetting the original profile again instead. I don't understand why it does that. It must be part of the architecture. In my mind, it's just a nonsense. It's a real nonsense thing, but it is what it is. So sure enough, I have to select the original line, and there you go. Does that answer the question? Is that the right thing?
I've just asked if it was the offset that Gareth meant, and he's put yes. Yeah, that's fine.
Brilliant. That's awesome. All right. So how are you all doing so far in following this kind of a little bit more of a technical side to some of the tools and some of the appearances in Fusion? Okay. If you've gone asleep, that's fine. You know, if your eyes are heavy, that's okay. All right. Just watch it back again. Okay. So next is browser organization. Joy. It's important. Browser organization is important. As you can see, when you've got crazy things like this, you need to be organized. I'm a stickler for naming files. I do not like it or appreciate it if someone says something is called Untitled 1. It is a no in my book. And when students do that, I tell them to rename it. It means nothing. It's, you know, we've all come across it. You only have to take a photo on a camera, a digital camera, and it will name it image, and a number. But number's meaningless unless you keep a logbook, okay? And I don't know anyone who does that. So naming is important. It's up to you how you name it. It's up to you whether you name it or not, because at the end of the day, if it's your work, that's all that matters. I thought I'd renamed that. Oh, no, it's good. Okay, so there's particular things that we're going to look at with the browser, and it's not necessarily the naming as such. It's things called groups, okay? And it's like, well, why do you want grouping? Okay, now the thing is with grouping, it's because sometimes you create objects, like this is not the best one because I've done, cradle interfaces, splices. So for example, I've got a folder there under bodies. It's called splices. Now that's a group. To create a group, you basically go to where it's got the body, the file body, you know, so there it is. I'll open it up and you right click on that and it says new group. And there it is, group 4. What a terrible group to be in. Okay, group 4. So I'm going to call this demo. That's all this is. But the real demonstration is here. So for example, I've got these cradles here. And you think, well, you know, what did I use that for? Well, I use these cradles to I use them as files to make something, but I don't want to see them. And the important thing to note is that, okay, there's only 4 of them, but you might have something that has dozens in there. You might have 100 objects. It is a pain having to select them all individually. At some point you would have to, but generally if I wanted to use that, I would want to make it visible in one click of the button. Boom, there you go. And that's why we group stuff. Okay? Grouping is important. So for example, this is the Cradle interface. Yes, I have to turn them all on. There's a reason why I turned them off. It doesn't matter. But there you go. Now these aren't, they're not that many objects really, although these are actually halves. They're half cylinders. Okay, like half a cylinder is called split down its axes. Okay, it's just a way of organizing. And so grouping is really important because otherwise you will have that as part of your body. So my body's here. The only bodies I'm interested in are ooh, I've lost them. The only bodies I'm interested in are these bodies. I'm not interested in those, but I keep them because they could be useful as tools. Okay, and that's it. That's grouping for you. Has anyone got a question about grouping? Delete contents. There's nothing in there, mate. Okay.
Sorry, is it just a case of like left clicking on each one with shift on and then selecting group the ones you want to group together?
Yeah, absolutely. That's exactly it. Thanks for pointing that out. Because it's like, how do you do it? Well, okay, I'm going to show you how you do that. Right, how you do that. So not that one. Let's have this one. So, okay, within Cradle interfaces, I'm going to go new group. This will be the demo group. So it's you know, group 4, G4S. Demo. All right, so there's the demo. And so it's like, well, which ones do I want to select? So I'm going to select the top one. I'm going to hold shift, select the bottom one. I might hold control, and I might individually deselect the ones I don't want, like those guys. Okay. So while they're highlighted in blue, I'm going to right click on that, and it's going to go, oh yeah, move to group. And sure enough, I've got those surface groups to move. So you can move groups within groups within groups. That's very complicated. And then the target group is demo. And only select one target group, and then you go OK. And sure enough, demo contains those groups within it. That's how you do it. Obviously, I don't want to do that, so I'm going to go undo because yeah, I don't need it. I don't want to spoil the apple cart, and this thing is designed for apples anyway, but excuse the pun. I hope that answers the question about groups. I hope that clarifies that. I was getting a bit ahead of myself, so thanks, Ian, for pulling up on the reins there. All right. Okay, so that's grouping. As you might notice here, though, I've got things called components. And components are interesting, kind of. The thing is that this is just one project. Sometimes I would have had it as a single maths. You know, I would have had this. I would have had these as separate projects. But it's handy sometimes to keep things all within the same general project. Now, components are they are what they say. They are individual objects. Now, but there is a difference between a component and a body. So a body, I'll turn this on, that is, there we go, it's a portland block there. I'll use that to delete material that I don't want. Okay, so that is a body. That's all it is. It does not contain sketches or constructions and stuff like that. Yes, I can generate sketches and construction lines and whatever, or construction planes from it, but it doesn't have any of that. They are all contained within this thing here, the original file that I created. Okay, and that's great. You know, the thing is, yes, I could have created all of these different versions within this one version, but then you'd have a list of bodies, for example, and features that are so long that most of them are not relevant at all. And it's a real problem. It's not fiddly creating components. It's not fiddly using them. It's just getting your head around the idea of how you organize stuff. Okay. Now, you might have noticed something a bit interesting going on here, and that's like this thing here. It's got extrude there. And usually you would have your parametric line at the bottom. Okay, it would have a line of the processes that you have used throughout. On components, they're here. Okay. Well, in my case, they're here, and it's probably because I have blah 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 history. I don't know. Yeah, it's not history. Sometimes you can turn off the history, and maybe I could have done that. It doesn't matter. Oh yeah, capture design history. Okay, and that's usually like if that's turned off, you don't have anything parametric. So there you go. There's the design history. Okay, so if I select that, well, unfortunately, yeah, I didn't capture that to begin with. So that's something to be aware. If you want parametric to work, you need to capture that design. Well, there we go. It's all in that group. It's in that one group there. And so if I select another component, it'll have a different group of features. It's fascinating, but there you go. All right, now in order to create a component, you can do it in a number of ways. So for example, yeah, what's all that? Let's just turn that off, and the sketches and the construction. It's just crazy, that is crazy. Okay, so in order to create a new sketch, if I hover over that, that's just showing me kind of what's in the folder, bizarrely enough. If I right click on that, I can go to the component. It's just, and yeah, standard. Sheet metal. Well, I rarely use sheet metal. Don't need to. But I use standard, and then it's internal. And what that means is by having it internal, it creates it. It means it's part of this. So these components are within this overarching component here, this main one at the top. It's kind of part of it. External, it will put it elsewhere. And of course, you give it a name. The parent is selected, so I could actually select that as a component as the parent. There you go, and then under it is another component. I don't want that, so I'll undo that. So that's one way of creating components. But the thing is, with components, it's all about how you organize stuff. So as I said, if I open that up, it has its own origin. Sure, there's another origin up there. It has its own bodies, and it has its own sketches and construction. Okay? It keeps everything neat and tidy. And when you're doing complicated work, well, it doesn't even have to be complicated. It's very, very handy to have this kind of stuff. Now, the thing is, when you do use components, it doesn't mean that they can't interact with other objects. So, for example, if I go bodies here, I've got label text here. Yeah. I have to select it. There's a little circle there. If I want to activate that component, there it is. Label text. Boom, boom, lovely. Let's turn it on so you can see it. Okay, so I might want to interact with this, or I might want this to interact with something else. So, for example, I'll leave that there, and I say, oh, okay, maybe I want to use a sketch from another, whatever. I mean, these are probably the worst sketches to use, so I won't use those. So maybe I'll use whatever's in here, whatever I can find. There's no sketches in there. Yeah. Doing well here. Okay, so what's that? Okay, so this is an example where you can create new components. So there's a combine tool here. It's part of Solid. Surface doesn't have one. Solid does, and it's under Modify. Combine, really handy. And I've got a target body. I want that to be the target body, the thing you can't see. So I'm going to select that. Why it's doing all this nonsense, I don't know. It just does occasionally. And the tool body is this thing here. Okay, now I could join them together. There's no point in that. Alternatively, I could intersect them, create a new component, and keep the tools. I'll keep the tools because obviously I don't want to lose my work. And basically that will create that or aspects of it, or I could just cut it. All right, and I'll go, okay. And at the bottom here, there's that new component. Obviously you can see the other things are still there because they're still in use. So let's turn that off. Let's turn that off. And there's a component that's shaded because it's not active. So if I activate it, there you go. All right, so that's how you can make new componentry. There are other ways, of course. So for example, if you're creating a new body for example, right, so for this, if I say I want to extrude that, right, yep. At the bottom of most dialog boxes, this dialog box here, you've got operation. It's always important to be aware that operation exists. I could join that. Well, I've got nothing to join it to, so it's null and void. I could cut it and intersect it. There's nothing to cut, intersect, or join, or whatever it to. But I can create a new body, and that will create a body within that existing open component, or I can create a new component. And there it is. And within that, that body has its, there we go, turn it off. Turn that off, there's nothing in there. And sure enough, that body exists in here with its own origin and its own powers to create sketches and whatnot. And that's, in a nutshell, is it. I think I've covered everything about, yeah, that's it. Is there any questions regarding any of that fusion stuff that I've covered?
No text is present.
Oh, look at that. So, I was just doing a quick demo here. That's where you can take surface and you can then do things like revolve. Absolutely. That new component. Okay. I've inadvertently created a P. So there you go. Amazing. Fusion is amazing. All right. Okay, so I'm a bit ahead of schedule, which is okay because that means I'm going to talk about something else. I'm going to talk about part 2. Okay, so in part 2, I want you, if you've got it, hopefully you've got it, I want you to open up. I've just got to drag it onto the screen. Now, can you see that? Can you see that, Ian?
Yeah, got it.
Okay, this is PreForm. Okay, I've got a model on there. Don't worry about that. But this is PreForm. We're going to be looking at PreForm. And so what I want you to do, I suppose, I want you to create some kind of three-dimensional object. It has to be a solid. I'll get rid of that for the time being. It has to be a solid object like this donut here. And then you've got to export that as a .stl file. And so if you're unsure how to do that or forgotten, it's not a problem. You go to your browser, boom, 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 and find that body, that item that you want to export. And you right click on that, and there it is. Save as STL file. And you get a dialog box there. Just save it as high refinement, unless it's massive, in which case don't make anything too big. I mean, I've no idea how big that is, but it doesn't matter. Okay, then you save that as, save it locally to your desktop, give it a name that you would know what it is. Okay, and you're going to use that for PreForm, which we'll be looking at after the break. Okay, I'm not going to bother with that, and the reason being is because I've got this. This is what I've got, because that is one of these. These are 3 of them. So this is this again is this SCP work, I'm not exactly sure what it is, but it's something that a colleague Cuddles, God bless him, it was his last day today, his last proper day is before going up to Manchester. So he was designing that, and this is for electronics, for Arduino stuff. So, and this is to do with SCP as well. So he's asked me to 3D print the bit inside, not the outer case. And sure enough, I mean, amazingly, he has labelled stuff. He's come so far in. So there we go, outer case, top lid, sensor board, top case. Oh, what was it? Oh dear. Board, sensor board. There we go, top case. So I would export that as an STL file, which is what he's done. He's given me all the files, which is very kind of him. Okay, and then I took that into PreForm. Well, he took it into PreForm, saved it, and then sent me the files. All right. So that's what we're going to do. Okay, so I'm just going to run to get some props, and in the next.
Just before you do that, Owen, sorry to interrupt.
Yeah.
Can you just show them where the import
in PreForm
feature is in PreForm?
So when you open stuff, first thing that happens when you open PreForm is that you get job set up. Now I've got a printer here called Shrewd Tadpole, and there's another one called Dark Antelope. You won't have these. These are the actual names of the machines that we have in the lab. You'll have virtual printers, and you'll be selected. You've got Form 3. We have a Form 3, and there's a Form 2. The one that I want you to select is Form 3, virtual printer. There you go, and say select. Okay, and in here you can select things like your materials. Now you can select these at a later juncture, but in this case I'm going to select clear, or yeah, I'll select clear. Print settings are default. Just have default, don't use beta, and we'll have a layer thickness of fixed. And you apply, and this little guy appears. And you can use the roller on your mouse, if you've got one, to zoom in and out. If you've got a trackpad, I'm not sure how that will work, because I know someone is using a stylus and a pad. But yeah, you go to File, just won't let me open it.
I think it might well because it's on it's on different screens within a session. It is just, I think if you do it yourselves, you'll probably find that the file will open. I think it's when you're sharing screens, you've got multiple screens on. It does affect the functionality of some of our CAD systems. Should we take that break then and come back in 10 minutes?
So, okay, welcome back to part 2 of session number 4. And for this session, we're going to look at 3D printing. I've got you set up with PreForm. And the reason is I'm going to kind of do things a little bit topsy-turvy, I suppose, in a way. Because at some point, I'm going to be moving my laptop and my camera and my sorry self over there. I've got a tripod set up, and I'm going to stick this guy on that, and then, I don't know, we'll see how it goes there. Live cameras don't work on live television and animals and children, apparently. Okay, so the first thing we're going to talk about is 3D printing and the types of 3D printing there are. Okay, so 2 weeks ago, Ian looked at, he demonstrated fused deposition modeling. This was created using fused deposition modeling, okay? As was this, okay? As was this shoe, all right? Now, the reason why I've got these models is because I've also got these and these, all right? This was made on a printer that has a dissolvable filament. So all the support material, we've dissolved it away in water. But it's important to understand that the reason why you have to have support material is because you can't print in thin air. It's got to have something under it. Okay, so in that purpose, this is not truly 3D, it's 2.5D. It's an unusual one, 2.5D. Who made that up? This one was also printed using FDM, fused deposition modeling, but it has a solid support of the same material. And it's rather garish red. Okay, and you would just pick this off, you'd pull that away. I'm not going to because it's a demo model. So you looked at those. Today we are going to look at selective laser sintering, which I've got a short dodgy film that me and Cuddles made. And selective laser sintering is this kind of thing here. I don't know if you can really see it that well. But you can see the layers. Now this is made out of nylon powder, polyamide, but it's a powder, and it uses a laser, and it lasers the parts that it needs to laser, that are particular layers. And where that laser strikes this powder, it sinters it, it bonds it together. It's really hard. Yeah, it's really hard. It's good stuff. It's expensive. But the thing I'm actually going to do a demonstration on, live demonstration, is this. Or should I say this? It's upside down. It's printed upside down. And this is stereolithography, SLA printing, okay? And as you can see, this needs support material. This doesn't, because it's printed in a bed of powder, layer by layer. It's almost like, you can imagine, we used to have a printer, it's called blow printing, and it had a print head, literally a print head, that would print super glue, cyanoacetate, onto plaster of Paris, and that would bond it, and it would do it layer by layer, as if it was printing on a sheet of paper that kept dropping, and another sheet of paper was placed on top. That itself is called long printing, but we don't do that either. All right. Now the thing is, how do they work? Well, I've kind of told you how they work. This is basically a hot glue gun. If you haven't used a hot glue gun, fair enough, but a hot glue gun is basically a heated element and a stick of some kind of plastic or resin or whatever, and you force that through, it heats it up, it melts, and it just extrudes. So this is basically a hot glue gun that goes around, 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 depositing a layer of this molten plastic, this PLA, polylactic acid. It's not an acid, okay? This selective, not selective, stereolithography, like this, it uses a laser, but it has a build plate, which I'll show you later. And where that build plate is submerged in this goop, I will show you that goop plate as well. And where the laser strikes the build plate, it fuses this stuff, okay? And then it builds upwards and outwards. And there you go. And I've kept the support material on purposely. Now, the thing to understand is that these printers, when you're designing for 3D print, you have to have this kind of thing in mind, because these printers they have their limitations in that you can say, for example, this shoe, FDM printing, could you wear it? No, you couldn't. For a start, it's a size 3. It's far too small for my foot, and that is a killer heel. But the bottom line is that that will break, that will snap. It's too rigid. It's got no roll to it. So, you know, this was 3D printed with the express purpose of being a demonstrative thing to demonstrate, like I'm doing now. However, if I printed the heel or even the whole thing using this technology, selective laser sintering, you could wear it. All right. It's something to bear in mind, that the process that you use must be fit for the purpose that you've got for it. If it's not fit for it, then maybe you shouldn't use it. I mean, you know, maybe that's all there is, and that's fine too. Now, there are pros and cons. So, for example, FDM printing, okay? These are FDM printed brackets that I've made. I've got 3 of them. They're for a cantilevered shelf that I want to put in the window. You can't see the window, it's behind you. All right, but it's a cantilevered shelf. Okay, great. The thing is, though, you might notice that this is a bad example. We find a good example. Oh, man. This is a good example. It's here. It's warped. It's warping. And what happens is that this was printed on a hot build plate, 60 degrees Celsius. And what happens is that that heat remains, and as it gets printed, it also cools. So you get differentials in the heat, thermal differentials, and sometimes things lift, sometimes they just warp. It is a downside to this kind of printing. Now there are ways of trying to negate that by clever design. By the orientation that you print it out. I could have printed it that way up, but then I would have had some kind of support material issue there. You know, there was all sorts of kind of technical problems. Or when you lay this out in Cura, you could put a really massive brim on it with basically a draft shield. I use draft shields not to keep the draft out or in, just to give it stability. Okay, so you can use Cura for things like that. So this is a problem with FDM printing, but it is fairly quick and it is relatively cheap. Now, I was going to work out the relative cheapness of such things. I forgot to do it. But I can tell you that this is about, to our students anyway, 5 pence a gram. That's pretty cheap. So, for example, right, someone's got their camera on. Rojan, you've got your camera on. I can see you. If we scanned your head, yeah, and 3D printed it, it costs £25. It would take like 5 days to print. We know that because we've done that, okay? And it's fast, so it's a really good thing we use. We use it a lot to make molds, rapid prototyping, shape and form, all sorts of things we use it for, okay? This stuff, selective laser sintering made of polyamide, it's really expensive. We don't even know how truly expensive it is. We kind of had a spreadsheet to try and work it out, but it needs tinkering with. Now, luckily for you guys, we can actually print stuff for you because it was bought on the SCP budget and the materials too. And so that's why I've been printing things like crazy. I've been printing 1 or 2 things with it. It takes a long time. So this shoe here, this took 21 hours, and this had full support in PVA, polyvinyl acetate, polyvinyl alcohol, which we dissolved in water, okay? And that was the full size deal, size 3, if you've got a size 3 foot. To print it on the machine that prints this, and we're going to look at that in a moment, I've had to scale it down. So in a kind of creepy way, it's almost for like someone who does like child beauty pageants or something. So it won't be out of place in Midwest US. But sure enough, a small child could wear that shoe if they so wished. I wouldn't recommend it though. Okay. A, it's expensive. B, it's going to take 48 hours to print something smaller than that. And that doesn't include the cool down time. But the advantages though, and it isn't really demonstrated with this, it's probably more demonstrated with something like this, which was a shell that I then elongated. It doesn't need any support at all, as I said. And the finish can be sanded, and I'm printing something to a really, really high finish, high degree. So there are those bonuses, right? And that's really sharp. That's a really good thing. Finally, stereolithography, stereolithographic printing. Oh yeah, one other thing about this, in comparison, well, I'll do that in a minute actually. I'll stick to the plan. So this stuff is printed from a liquid resin, okay, and it's a it's not a biocomposite. What on earth am I saying? It's a composite material. Don't really know what it is, but what we do know, it is very sensitive to ultraviolet light, and so that's why we use an ultraviolet light ultraviolet radiation laser, okay, to create this stuff. This is cheaper than that. And the reason why it's cheaper is because when you print something like that, the material that's left over, you can only use a few times. So you end up having to pay a percentage of the whole volume of material that's being used. God knows how much it costs. I don't even know how much that costs. 50 quid. No, it's not even that. It's, you know, but a lot. For this works out at 17 pence a gram. So, get the red one. 5 pence a gram, 17 pence a gram. There are other materials. They are dearer. So, for example, we could use it a castable material. So, if I wanted to make a ring, we could create it, 3D print in a castable wax. It'll go to our jewellery department and they'll burn it out, cast gold into it. But that material itself is about 35 pence a gram. So you see, there's a scale of economy. And if you were in dentistry, you can actually buy materials that you can make dentures with or molds. And that is really expensive stuff, but we don't bother. Okay. All right. The other thing to bear in mind is that with these printing machines is that how big a unit can you print? Well, with our FDM printers, we can print fairly big objects. We can print objects bigger than that. It takes a long time, it takes longer, but the scale of things is just better. This has got a small print bed, really. I haven't really. Hold your horses. I'm literally just going up there. Now, this is called a try-on RAR, which is a representation. Excuse the bit there if you didn't see that. It's a representation of light in the 6th dimension, I believe. Okay, so I've designed that for a student, and that would fill the full scope of that SLA printing machine. Although you can print fairly wide objects, but it's small. And the printer we're going to see for that even smaller still. So when you're designing stuff and you're designing it to be 3D printed, you have to ask yourself, is the printer big enough? If not, are you going to have to make something modular? So one of our other SCP participants who was on the advanced level that finished yesterday, he had been making a picture frame that clicked together that was 3D printed. So he could make any kind of size thing he wanted out of this printed material. Why? It doesn't matter why, just because he could. Okay. All right. So now the main con of these things is the materials themselves. So with this kind of stuff, PLA, polylactic acid, this is a bioplastic. It's made of starch-based material, so it's vegetable-based. And how it's made is that they basically brew beer. They make beer out of maize, and it's got no hops. You don't drink it, and that beer is then distilled into alcohol, pure alcohol, and then they catalyze it using something called tin oxalate. So bioplastic, but it is not compostable because of the tin. Because if you start sticking that into your food chain, you'll end up eating large quantities of tin. Bad. But you can buy materials that are fully compostable. It is clean. And the cleanup for this is simple. It's really self-contained. I really like it. This stuff is powdery nonsense. I say it's nonsense because it gets everywhere. And we have to wear a respirator to use it. Mainly because you don't want to be inhaling nylon, but also because the particle size is so small, it's probably carcinogenic. In fact, I'd say it's definitely carcinogenic. It's the equivalent of sounding MDF. You'd have to wear respirators for that too. Okay, but it just gets everywhere. It's mucky, dusty. And this stuff, well, this is a resin. It's goopy. It's sticky. You have to use isopropyl alcohol. And believe me, 14 months ago, isopropyl alcohol globally was very expensive. And we use a lot of it to clean this stuff up. So the alcohol is bad for you because it absorbs into your skin, into your bloodstream, but also the resin, it just gets on your hands and it's just messy stuff. So there's the main con really with these kind of materials. But in terms of definition, superb definition with things like this SLA printing. You get, I mean, it's whatever you're happy with. I mean, we do make some very interesting stuff out of PLA. That looks the print quality of this compared to how it would have been 10 years ago. Whoa, worlds apart. And this stuff, well, this has got a rough finish, but I know for a fact that shoe on printing is going to be ultra fine. I expect high things. Okay, so that's basically the ins and outs of the printing. So what I'm going to do is I'm going to show you a short film. Yes, I am. I'm going to show you a short film of the SLA process. There's no sound to it. Well, there is. It's just me and Cuddles like guffawing or, I don't know, messing around. You have to excuse the quality. I literally just knocked this together within a couple of days because I wasn't going to talk about this process, but actually we've got it. It's interesting. It may be of interest to you. If you switch off, that's all right. I won't be offended, but I'm going to talk. So I'm going to share something. Okay, so this is a Selective Laser Sintering machine. It's a big black box. There it is. I've just turned it on. It's got a key switch on the side. Activate that as well, some kind of security function. Okay, takes a little bit of time to boot up, and getting this thing ready to print is slow. It's a slow and drawn out process, but once it's printing, you just leave it be and it will do exactly near enough what you want it to do. So previously I'd cleaned it already after its last job, and now I'm uploading Pigali. That's what that shoe is called. That I got that off Thingiverse because I am not that good a designer. I'm certainly not a cobbler. A cobbler, obviously, if you don't know, someone who makes shoes and footwear. And so I got that off the internet via Thingiverse. Now, so it's got an interlock on this machine, and you have to unlock it. And inside, yeah, I've done all that. So it's going to ask you questions like, have you removed the print? Have you cleaned the hood where the laser is? Yeah, I've done all that, and you can hear me saying I've done it. And so now we've got to position the beds for printing. Now, this is a slow process. It's really slow. In fact, I think Cuddles, he just stopped it because it was just like watching paint dry. But what's happening is that this machine is homing, okay? So essentially, you've got two hoppers, okay? You've got, let's just turn them off because I can hear. You've got a hopper on the right there. That is the print bed, and that usually starts in a raised position. And on the left, you can see that drop in. That's got some powder in it. It hasn't got much powder in it. That is the powder bed. That's in its lowest position, and we fill that with powder. Okay. In this case, polyamide, which in this case again is nylon as opposed to Kevlar. Now that bar going across, that's called the sweep bar. So the principle is that hopper is full of powder, and as you can see on the right there, that print bed is raised high, and there's me just filling this stuff up with this ghastly powder, this expensive ghastly powder. Okay, we fill the hopper up, we tamper it down, and once it's ready, that sweep arm pushes a fine layer of powder over that print bed. Okay. I mean, I was hoping that Cuddles didn't film all of this, but maybe he did film the whole lot of me filling this up. Maybe I told him to. Now, the thing is, as I mentioned, that you can use this powder again and again, but only a so many amount of times. Okay, so what happens is that, oh, there we go. I'm just tampering it down. You notice I'm wearing gloves. This is the kind of thing you don't really want to get on your skin. It causes irritations. I mean, miraculously, my arms weren't covered, but I was okay. Okay. Now the thing is, as I said, you can use this powder again and again, but you have to cut it with brand new powder. Okay. And the problem is, how do you mix such things? Well, we've got a cleaning device that shakes loose powder off objects that we've already printed. We'll have a look in about 4 minutes on this film, and we can mix the powders that way. If you don't do that, you'll get massive inconsistencies with the print. And this machine hadn't been used for like 14 months up until now, or yesterday, or whenever. And when I come to print something, you can see that later. you've got inconsistencies in its level, in the quality. Right, so that print bed is now totally covered with a very fine layer of powder. That arm has done a really good job at moving it along, and it's done the leveling. And then we just start the printing. The print itself was uploaded from a piece of software called Sintering. I didn't get you to download it. I'm not even sure if you can download it, but you have to upload it via Wi-Fi or via USB. Now, the thing is, this machine heats up to 108 degrees Celsius, and so before it'll start printing. After it's, once it's got to 108 degrees and once it's printed, there's a long cool down time. It takes hours and hours. So even though the estimate will say, oh, it's 48 hours to print, or in this case, this thing that you're going to see that was printed here, which isn't Pigali, it's something else, because I printed this, we did this on Tuesday, Tuesday, yesterday. This took 71 hours and plus a cool down time of probably about 10. All right. So what happens is that once you finish printing, and this was a big object I printed, this was for another SCP student, and it was that horn type thing that I showed you with the fusion demonstration. You have to get this block of powder out, and bear in mind, it is still powder. Okay. Now, when I was saying about it self-supporting materials, don't need support structures, this is why. Because what happens is that that feeder arm pushes the powder over, the print, the laser activates, it sinters the material, and then the print head drops, and it repeats the process again and again. So now I'm just carefully removing the this powder to find that the objects inside. What you might not notice, well, not necessarily initially, is that I am wearing a respirator to do this. And there's the object. So, and this was the object that you would have seen me using as part of the demonstration in Fusion. Okay. Now you might be wondering what it's for. You'll see. You'll see. So this was, as I said, for another SCP student who was doing the advanced course. Okay. So cleanup is a bit of a faff because you've got to get this powder off. So we use a brush. You can imagine this stuff getting everywhere. And you can just notice there, actually, there's part of it, the finish doesn't look so good. And that's because the powder really wasn't mixed properly. That was probably virgin powder, so to speak. Okay. Once we've got most of this stuff off, we put it into a shaker. Okay. Now, this material that has been bonded is really hard. It's very hard. And that's partly the reason why I did it. And it also was redesigned because this was initially, this was two flat plates that stuck together, but they warped. So now I'm sticking it in this shaker. And that's it, you press the button and it shakes. So you can see the powder on my gloves, it's just everywhere. Now there's an overflow because as that arm pushes material across, it pushes it down into this letterbox. That is full. I didn't empty it out. I didn't empty it out on camera. It was just, I just left it for another time. Now we've also got like a bead spray where this has got sand in it, and that in a way is used to spray the residual powder off this this item. It took a long time. Eventually you also end up washing it as well. That's not a good thing though if you did wash it, or you would have to wash it, because you've got to bear in mind that these are microplastics, and when I say they are seriously tiny. This is a powder. These are not like tiny microscopic beads. They are, you know, very fine powder. Okay, so it's ready, and this is Jess, who was one of the participants. She's got a wet piece of paper. She's got her press. You can see the terrible finish on one side, and this is all it was for. He says, so she's a textiles artist, she makes textiles, and for labels, she wanted a way of embossing damp paper that she will make herself, and it'll have seeds in it. And there you go. One pressing tool designed in the SCP and made in the SCP. And that's it. Amazing. Okay, right, so what's going to happen now is that, what time is it? It's 7:38. Look at that, that's perfect. I mean, my time is pretty good, you know, because it says 7:35 on there when I was finishing. So what's going to happen is that I'm going to move this laptop, that camera, and everything else myself over there. So you're going to just bear with me. If you've got any questions, Ian is there to answer, maybe. So if you don't know, this is the Fab Lab. There you go, 360-degree view. And there's the windows I was telling you about with my plants on there. That's the only reason why I'm making shelves, because I want to put my plants on them. This is the Selective Laser Sintering. It's working as we speak. There it is. So there's a little black line there. That's been sintered by a laser. Can't really get the focus on it. Oh, no. That block there, that's the laser itself. There goes the sweep arm. That's giving you another layer of that nylon, and the laser's doing its business. Those lights you can see are inside there, they're heaters. Yeah, so this is 177 degrees Celsius in there, so it's warm. It's warm. Right. Okay. So this is stereolithography. Okay. And I'm not saying that's finished here. Okay. So I've just got to run with you what actually is going on. I'm going to give a different quick sheet, so I stay on topic and don't drift off. So I'm really good at that. Okay, so we've got two of these machines. Okay, this is a Form 3. Okay, and well, over there, which that's a Form 2. That's the first machine we got. We use it for specific jobs actually. So this one we use for mainly plastics or composites that are like clear composites. We might use them for dark materials like things like that, or white. We can use them for tough materials, and they have properties similar to like ABS plastic or nylon. Really, really hard stuff. Even flexible materials as well. They go in here. The kind of detail that you can get from this machine is like this. Is that clear, Ian?
Yes, it is. Yes, it is.
And so basically, this is the test piece. This is the coin that one of the students creates. It comes from a family of coin makers and metal makers. It's really good at it, and it also includes the sprue that would be used for the casting process. Okay, that's the piece. So, what's the anatomy of this machine? Firstly, we have a cartridge. This cartridge will have a very specific material in it. In this case, it's clear, so it will produce clear objects like this. Well, it doesn't look so clear now, but it will do. Okay, and this material here is very specific to the thing that is called the tank. So this is the tank. And basically, it's a tray that has an arm in it that sweeps it backwards and forwards. And what happens is that during the pre, this tank is filled up with this carbon. So it comes out the bottom, it squeezes out the bottom, it fills this tray up. And that means the level is consistent with what you're printing. And that's really important if you're printing large objects, because you don't want to run out of materials. That is a real pain. Okay? So this thing here, this is called the build plate. And as you can see, I've got a crystal clear robot on there. My wife loves robots. I print many of them for her, all different materials. But I've got this as a demonstration piece, and we're going to use it. Okay. What happens is usually is that we can generate a file in PreForm. And then, in fact, I kind of skipped it. It's going to be PreForm first, but never mind, we'll do it last. You generate a file in PreForm, and you can either save it to a memory stick, plug it in the back, or you can upload it via Wi-Fi. We use Wi-Fi directly to the machine. It also means that we can monitor the machine as well, without interfering. So that's why I'm just going to put that guy back in there for a second. Now, generally speaking, what happens is that when you set a print off, when we set something off the print, it has to warm up. Sometimes it can take forever. Forever. The options for which you skip that often, but we usually have some kind of stick to show you the good. But I don't. In fact, I do on the filter. There's stuff in the filter. You can see, I don't see that this stuff is particularly. I don't think it's fingers, but you can see that as the light reflects on it, it's actually really quite viscous. Alright? Not pleasant. But I want to show you how we deal with that as well. Okay? And to be quite honest, I'm putting a cart before a horse, so to speak, yeah? Because usually we send the cart to print, we print it, and then we show the cleanup. But it's easier for me just to show you the cleanup and then the sending of a brand new cart. Okay, so that's what we're going to do. So once this is finished, take this out. It's for the position of the to look at this box in, which you can't see. We'll do that now. How we clean these things up, we use this thing here. This is like a deep fat fryer. It does not contain fat, it contains isopropyl alcohol, lots of it. And it does get sticky because this resin sticky and gets everywhere. We've got down here. We can change the duration in the bottles. I think it speeds. It speeds agitates the alcohol and it cleans this of this excess material. So 7 to 10 minutes, and that's about usual. Sometimes it might be a bit longer if it's a larger piece. The problem is, this hasn't been cured. Okay, so yes, it is bonded by ultraviolet light, but it needs to go through a hardening process. If we don't do that, and we let that soaking in alcohol, it will dissolve. We don't want that. So that's a good thing. And then just going to pop it in the place. And then just say it's gone.
Now, as the sound broke up just a little bit there, I'm just going to repeat that. It's alcohol within there, isopropyl alcohol within the tank itself, and the time it's in there is quite essential. I think the sound broke up just as Owen was explaining that. You can leave it too long; it'll just dissolve completely. So you could set something for about 10 minutes. Would you say, Owen?
Yeah, so I'm on camera, sorry. 7 to 10 minutes. And then after that, we'll take it off and we'll remove it. I'm not going to wait that long because we haven't got that long to wait, really. What I could do is upload, while that's doing, upload the other file to this machine so you can see its startup process. So that's probably what we're going to do now. So I'm going to take it off the camera and then share it another screen. Now this is PreForm, which you've seen. And now, because I've got it on, for some reason, it won't let me open a window on another screen apart from the main one. To open an object, you go to File, you go to Open, or you can go to Open Recent. Okay, so I want to go to Open Recent, which is in a case file. Okay, I mean, I could go to the robot and show you that, which I will do, because I love the little robot guy. So there's the robot that I printed as a demo piece. There he is. However, I'm not going to do that. I'm going to open the thing that I'm going to then send. So delete that. Go to Recent. Now, the thing is, the file that I'm going to open was already created and saved. Now, I could import it, or I could just open it as a new job. So I'm going to open it as a new job. And it's quite big. There we go. I'm going to dismiss that. PreForm likes to update regularly. Okay. So, as you can see, If I hold down the right mouse button, I can pan around to see the objects. And what you might notice is that this has a support structure, okay? And that's called supports. And on the left-hand side, there are tabs. Do one-click print. We can scale things. So if you've got something that's too big or even too small, we can make it larger. We can rotate. We can even nest the layout. But in this case, it's about supports. So if I auto-generate these supports, it'll go for a process. I mean, they're already there, but I'm just going to do it again. And theoretically, they should be in the same position. And if they're not, I apologize to Ben in advance, but he's left. So what difference does it make? Bless him. Okay. So that's done. And now it will calculate printability. Now, the thing to bear in mind when you are using this process or the process of selective laser sintering is that there are certain things that you cannot print. So you cannot print something that has a void inside it. All right. So for example, if you had a cube and inside that was a spherical void with nothing in it, if you try to print that on the SLS machine, it will fill full of powder. There's no way of it getting out. And on this process, SLA printing, it would fill up full of resin. And that's where it will stay. So if you're doing anything like that, there has to be drain holes so this material can empty out. Okay? Now it's telling me that it's going to take 14 hours or just over 14 hours to print. And that's the actual print time. That's not the heat up time. Tells me how many layers, and more importantly, it tells me the volume, how much material is going to be used.
Owen,
so, hello?
Sorry to interrupt, but Gareth's just asked, is this to design the insert for the Smart Citizens kit?
Yes, it is.
Yeah.
Absolutely. So we're going to print 6 of these, but I'm going to print 3 of them today, overnight, and we'll do the others maybe tomorrow, if you want, or whenever, Friday. Okay. Now down here you've got printability settings, and it tells you that it passes everything. There's a thumbs up, printability, so minima, show cuts. Beneath that, it also shows you what is going to be printed. So I've selected that one or that one. Yeah, they're all going to be printed. And that's it. So this is ready to go. It meets all the criteria for printing. Okay. Now, the thing to bear in mind when you're printing anything with PreForm is that you tend to need support. We very rarely print directly to the build plate. And the reason being is because certain things are very difficult to get off the build plate, especially if you're printing in something like ceramic. Ceramic is incredibly hard to get off that build plate, as Ian knows very well. Now there's a slide bar next to it, and that, if I scroll up, that shows you the process or the progress of the print. That's how it will do it. These machines are very gentle in how they move and how they operate. There's very, very little vibration with them, and that needs to be the case because you have these supports here, and these are very, very fine. Okay. So if I click on where it says Shrewd Tadpole, which is the name of the printer, I can select what kind of material I want. Obviously, it's got clear in there. These need to be clear. And Ben Cuddles, he's selected additive as opposed to fixed. And what that means is that there will be certain areas of the print that will have thicker layers, and these will be areas which have less detail. And then the areas that have more detail will have a finer finish. If I go to fixed, though, I could either select it at 25 microns, which is really small, or you can have it really large. All right. I'm just going to keep that, and I'll cancel that. So this is ready to go. So there's a button here. It says Start Print. Now, if you were to save this to a USB stick, that's what you'd do. You'd save it here. But in this case, we're going to upload it directly. And so I'll go to upload job. Do not disconnect printer. Well, these things do happen. It's never happened to us. It's not the fastest thing to upload. So generally we have to wait. But that's okay, because while that's doing, I'll stop sharing that. There we go. And as by magic, this is finished. Now, can you see that?
Yeah.
This is finished. In a different time. So I'm going to put myself in some rubber gloves. So I'm going to try, but I'm not going to remove this here. Unfortunately, I'm going to put the tripod back in. And then I'm right, so first we take this off, shake off the excess alcohol, and then we put this to sleep. This is not a good thing to have on because alcohol will evaporate. And we do work with this through. I mean, it's not like it's a demo, it's our spoken. And there you go. Isn't it beautiful? All right, so I'm going to grab this and this, march over here. So this is where there's the laptop. So this is where we clean. Okay, so this is what we used to have originally. This is basically a hand washer. We don't keep anything in that one, we just don't use it. The things that we do use it for are mainly for ceramic printing, because the nature of that material, we don't want it getting in with our general clean stuff. So we dip it in this tank of isopropyl. But I also use it for all sorts of other stuff as well. Okay, put the lid down there. Now, I've got a print plate here. That's all just isopropyl alcohol. How we get the prints off, there's two ways you can do it. For real stubborn guys, we use that. We've got to be careful that we don't use this steel palette knife on this aluminium coated print plate. If you scratch it, as you can see, this has got a few scratches on it as it is. It's all right though. Alternatively, we use this device, and that's a toughened plastic, I don't know, pick, and you leave it right under there. But generally speaking, we use a pair of like these side cutters, these wire cutters, and all you do is basically stick it there and just squeeze. I'm just going to capture that. Et voila! It's free, okay? It's not enough though, because generally speaking, you do not want alcohol on these objects when you cure them. And the main reason is because what I tend to find is that it doesn't cure properly. They can end up being sticky, and sometimes curing is not enough. It takes a long time to get rid of that residual stickiness of prints, okay? Particularly large ones. Now this is ready to be reused again, almost. I'm just going to give it a squirt of alcohol. I'm just going to wipe that down. There we go. Any questions so far? Sweet sound of nothingness.
No, we don't have any questions yet.
That's all right, man. Okay. Obviously, make sure we clean the tools up. Now, the kind of materials that we process, I said about the Form 3, you know, mainly clear, tough, flexible, black and white. You can get materials that do have colour. The other machine, we also use, oh no, I've told you all this about ceramics and casting. Yeah, I've done that, haven't I? So yeah, we keep those in the other machine. The other machine is for the more dirtier materials or the particular fussy materials. Now the process I'm going to show you in a minute is curing. So we're going to stick this in a curing tank. Okay. Not all materials are cured though. So for example, if you're using casting wax for lost wax casting, like in jewellery, for example. We don't cure it at all. As soon as it comes out of the cleaning tank, as soon as it's come off the bed here, we put it in a dark cupboard. And the reason being is because if we cure it, it changes the composition of the material. And it means that when it's cast in like plaster of Paris or whatever, it doesn't burn out cleanly. Okay, and that's not good if you're casting like 18 karat gold into something. I mean, I'd love to have one of these made out of 18 karat gold, it'd be amazing. Also very expensive. Okay, so what I'm going to do now, I'm going to move you guys towards the curing bath. And it's a bath in the sense that it will bathe this in ultraviolet light. Okay, and we'll have a look at that.
Got a quick question, Owen, if that's all right.
Yeah.
As we're going. I remember Kevin, who's one of our tutors for everyone who doesn't remember Kevin Jenkins, was telling me that when it goes through the curer, the curing process, the transparent colour, it slightly discolours and goes slightly yellow. Is that the case here, do you think?
Yes, absolutely. So we've got something that is really quite, people would describe that as white. That is transparent, okay? But it will take on a translucent hue and it will go yellow. Now, there's a way, it's not really a way of circumventing that, it's just the nature of this material. However, we could cure that in sunlight.
I was going to ask that.
Yeah, and that will take on more of a blue hue, okay? But it's very difficult. And I mean, the thing is, there's a lemon over there, I'll show you that. That was once clear, and that's becoming progressively more cloudy. It's just the limitations of the material, okay? But in terms of making prototypes for like glasses, for example, I mean like drinking vessels or anything optical, in an instant or within like, it's good for a few weeks at least, and it can demonstrate the potential of another process, like, you know, maybe you would want it blown out of glass, or, you know, you want to manufacture to make optics or whatever. You would use that process and demonstrate with this.
That's
but
great.
It doesn't last. Does that answer your question?
Yes, thank you. Thank you very much.
You're welcome. Right, let's go and get over to this tank. Brilliant. Now on the front it says UV cure bar, optical radiation, ultraviolet light, 365 nanometers, 405 nanometers. It will burn your skin if prolonged exposure. It will damage your eyesight. And it's not hot internal surface. So this thing is a number of seconds, but we can heat it up to, it says 60 degrees Celsius. I've never got it up to 60 degrees Celsius. But it goes to about.
Can I just ask a quick question, Owen? Yeah. Gareth's just asking, what are the benefits stroke drawbacks of stereolithography compared to printing in PLA? And I thought, well, I'll let you answer that.
What's the question again? Let me have a read.
What have you got that?
Yeah, hang on.
I can read it again.
What are the benefits, drawbacks, compared? Okay. Okay, I'll show you. I've just printed this. It's PLA. The benefit is a different colour. It is a biocomposite. It's really clean. I'm wearing other gloves, so I don't have to use this. It's simple. Yeah. The cloth is a bit scruffy. It needs support material. Finish is best. And it extrudes from a nozzle that's 220 degrees Celsius. So potentially you could burn yourself if they're little burn, but you still burn yourself. This guy, SLA, really high resolution, really good finish, and that's the bottom line, a really good finish. It is not a biocomposite though. It is mucky, it is filthy, and it requires things like isopropyl. Why would we use this? Because of the high detail value that you get. We make working prototypical items using this method. We want to get this using this method. We would use this.
Just bring them down a bit lower so we can see them, please, Owen.
Oh, yeah, sorry.
Yeah, perfect. You broke up a little bit there.
Maybe small objects like brackets, we would use that for actually putting resolved prototypes. Yeah?
Yeah.
So we would do all that, we tend to do all that preparation work, troubleshooting this, and then we resolve those design files that we use this. Always, like experience designers, so sometimes we go straight for this.
Okay, it broke up a little bit there, so I'm gonna just kind of recap that very, very quickly, and just correct me if I'm wrong, please. The red one's PLA. It's from our extruded printers. Very cheap in comparison. Very, very quick. You see the lines within the surface. The clear one, you don't see the lines so much at all. So it's much higher resolution. It's more expensive, and it's not as good for the environment. Because as Owen mentioned before, the extruded plastics can actually be degradable.
Yeah, definitely. Okay, so this is going to go in the tank. This guy, he's finished. He doesn't need any more processing apart from this green. It's good to go on the shelf. This one is staying here. And inside, there's arrays of ultraviolet like emitting diodes. And the bottom in the middle, you'll see, well, the bottom there, you can see. And it's only a small phone, so it says start. Now the thing is, you're not going to see anything unless I do this. There you go. And sure enough, that is UV light, and that's why it radiates. So, it radiates. Alright, so he goes in there for I don't know, an hour. Easy. Okay, so I'm going to drop this down and we're going to have a look at the 3D printer. We've got a job sent through at home.
So the file that Owen sent should have actually been sent to the printer. Is that right?
He's not home. Right, here we go. So, on the screen here, it's got the previous print, which was the logo. Was it rubbish? No, it's great. So, okay. And it's only two or 3 years, clear, 3.4, 3.4 version 4, clear material. That's already loaded, okay? You could do something called priming, and you can do on this machine, not on the material. And basically, it pre-prepares it. So, for example, if I find this machine, I could just go away. I could actually go home, and then I could send a file to it, knowing that there's no other file on it, and then it would start printing. It's pre-prepared. I sometimes use it to save time. So, okay, I select that, and actually there's a little arrow there. Go like that, it tells us details. It says it's going to be ready in 40 minutes to 22 minutes. So why? Be longer than that, but not by much. It tells us the material, the amounts, and it tells us how many layers there are going to be. And it's going to be 930 layers. Okay, that's great. And then it prompts you some questions. So firstly, open the vent cap so your resin tank feels correctly. The thing is, if you try to, you try to squeeze something out of a plastic bottle, air will try to escape upwards into it. That's why we open this cap here. There we go. That will let air into the top, and so gravity will take effect. Okay, and there's no vacuum inside. Okay, so that's good. In shorthand, to secure the build plate. There is no build plate in there. If I try something, there's no build plate. It will raise an error.
So just as the sound disappeared there, it just prompted Owen to check that the build plate is clear and that actually made him realize that the build plate needs to be put in. So the actual machine is prompting us to make sure everything's set up.
Yes. Here is the build plate. This is the proper build plate for the material. So we have build plates that are very specific to the materials we use. They're all the same. We could interchange them, but it's just one of those things. We don't want to cross-contaminate anything. So I'm going to lift this up, stick that in there, put that down. It smells quite nice, but it's probably bad for you. I know it's very pretty. And so what's going to happen is that it will fill up. It's checking the optics, and what happens is that under this bar, I'll show you with another resin tank. I'll show you with an old resin tank, a brand new old resin tank. There's a cover to prevent it from reacting with ultraviolet radiation. Oh, preparing. So now it's starting to fill. Now what you can see, there's a sweeping arm. I've got the alcohol there, and I've got some tissue because this stuff is mucky. It's violent. So it's got this arm that sweeps over the print bed, and this print bed, the bottom of the tray is clear because the laser needs to penetrate through it. But it's got magnets at the bottom, and what happens is that under here in the machine, there's a magnetic arm that sweeps backwards and forwards. And that comes into contact with the bottom of the print bed, at the bottom of that tank, which is upright, and that means that this arm will sweep backwards and forwards without actually being in direct contact with the mechanism underneath. Okay? Yummy. Yummy, yummy, yummy. Not. Now, the other downside to these machines is that these things, these tanks are consumable, and the build plate, they are consumable. Okay, that's filled up now. And so it's getting ready to drop down. So these tanks are consumables. They are not cheap. So for us to operate them, they are quite expensive. And the material is expensive. There is nothing cheap about these machines. But they are really good. They print with such quality. Yeah. For that, I really love them.
Just to let you know, the tanks themselves are about £150, and the resin, the litre tank of resin at the back there, starts at £120 for a standard resins and goes up in expense to, I think, £240 for the more expensive ones, such as castable.
Dental resin is from £400 for a litre. Expensive, but there's no reason for us ever to need them. Unless we had a client, like, you know, a commercial client who wants that, in which case we'll do that. Of course we will. So, it is 20 past 8. Has anyone got any questions? I mean, there's no real homework. I mean, if you do want to send us something to be like an STL file, and you want it sintered anyway, selective laser sintering, then I will do it. Obviously, we'll do it. You know what I'm saying? If you want items maybe on the form 3, possibly, yeah, we'll do that. But it's quite expensive. I know the sinter is really expensive, but it's all paid for. So, you know, we don't mind using it.
I suggest we keep the models fairly small, though.
Yeah, like tiny.
Next week, we're going to be trying something quite difficult, which is it's going to be 3D scanning, and also we're going to be looking at Mesh Mixer as well, and I'm going to try and make a film, I think, in a similar way that Ben and Owen have done with the Sinter machine. So that'll be next week's topic.